Let's get particular. Actually finding not general antiderivatives, but the actual antiderivative. Um, means we need a little bit more information. We need to know something about the actual function. So let's jump into it and see an example. So this is a finding particular solutions. So it's asking us to find some sort of function, right? So find some f of x such that its derivative. So we're trying to find an antiderivative. But what else it gives us is it lets us know what our answer is going to be. That we're going to get the answer is going to be 1 when we plug in x is equal to 4. We're going to get that our y is equal to 1. All right, let's back out of it. So let's write our f prime of x. And we're going to write this a little different. It's not going to be g and f and things like that. So let's rewrite our f prime of x is equal to, this is x to the negative 1/2 power. And we have some experience with this already. So let's go find its antiderivative. So we're just going to call it f of x, not big F of x this time, because f prime's antiderivative is just f. So we're going to add 1 to our exponent, and then we're going to divide by 1/2, or oh shoot, let's multiply by its reciprocal. Oh, but we got to write in plus c. So let's rewrite this in a little bit more of a friendly form. So maybe 2 times the square root of x plus c. So that's a general solution. But now that we have this, this is telling us, hey, let's replace that f of x. We're going to call it f of 4. So we're going to make our x, let's go through, our x is going to be equal to 4. Plus some c is equal to f of 4. And f of 4 is equal to 1. Now we just go through and solve for c. What is this? So 1 is equal to 2 times 2 plus c. So 4 plus c is equal to 1. We subtract it over. And we get that c is equal to negative 3. Well, boy, howdy, let's just write down our solution. I guess our function must be, I guess that must have been 2 square roots of x minus 3. So our c was minus 3. Well, there we go. We went through and we solved for it. F of x is equal to 2 times the square root of x minus 3. And there's your first particular solution. And we can do this for umpteen amount of derivatives. We can do this over and over and over and over, and there's some tricky ones that are in your homework. I like these. I like the systems of equations ones. You might want to take a look at those. Now this one is just to kind of get our pattern down. I think this is what? This is number 48 out of your text. This is like the last one out of finding these particulars. So let's go get it. Let's go get our f double prime of x. Right? You take a derivative, you would take an antiderivative. You're going the opposite direction. Right? You're going the opposite direction. So when you take an antiderivative on the third derivative, we're going to end up at the second, because we're going back the other way. It's 3 minus 1, minus, take it away. Cool. So this is going to be equal to negative sine of x. Oh no, I screwed up. We better be really careful with these. What has a derivative that equals cosine? Sine. Oh shit, being very careful. Check your SIGN. It's not the other side function. Plus c. But we're given a little bit of information right here. This tells us that f double prime of 0 is equal to 3. So it's telling us, all right, go plug in 3, and it's equal to sine of 0 plus that c we want to solve for. The sine of 0 is equal to 0. So we get that our c is equal to 3. There we go. So f double prime of x is equal to sine of x plus 3. Well, shoot, we got to go all the way down to f of x. We got some work to do. So now let's go find our f prime. So f prime, we're losing one. We're going to take an antiderivative of this down here. So what has a derivative of sine? It's not cosine, but what does have a derivative of sine is negative cosine. So we get this is equal to negative cosine of x. And now we got to find the antiderivative of 3. What line has a slope of 3? 3x. And now we write in plus, I'm going to call it something else and call it a plus d. Because why not? And let's move to the next. We got that f prime of 0 is equal to 2. So let's set it up. Say 2 is equal to negative cosine of 0 plus 3 times 0 plus d. Well, 3 times 0 is nothing. But cosine of 0 is negative 1. Oh, no. No, cosine of 0 is 1, but there's a negative cosine of 0, which equals negative 1. My apologies for misspeaking. Let's add 1 to both sides, and we find out that our d is equal to 3. Therefore, our f prime of x is equal to negative cosine of x plus 3x plus 3. So both our c and our d were 3. Neat. Well, let's finish this bad boy off. Let's get it. So f, oh shoot, let's go. F of x is equal to, now what has a derivative of negative cosine? It's not sine, but negative sine. Now we need to take an antiderivative on 3x. So we're going to add 1 to that exponent to make it a 3x squared, and now we got to divide by that number, that 2. So let's call it 3 halves x squared. Now from before, we found out the antiderivative of 3 is 3x. And now let's add it to something else. I'm going to call it, I guess I can do this, big E. It's not a little lowercase e with an implication. You know, I typically do C1, C2, C3, things like that, but first time, let's go. Now the last piece of information that we are given here is that we have an f of 0 is equal to 1. Our f of 0 is equal to 1, so let's go solve for that e and we can be done with this dang problem, you know? We say 1 is equal to negative sine of 0 plus 3 halves of fricking 0 squared plus 3 times 0 plus e. That's nothing, that's nothing, that's nothing. E is equal to 1. Therefore, our solution is f of x is equal to, actually, hold on, I'm getting all excited. F of x is equal to negative sine of x plus 3 halves x squared plus 3x plus 1. And there is our final solution for our particular, actually not final, our particular solution. Because this is exactly the antiderivative when typically we find general antiderivatives because we're not given these what we call initial conditions. And we call them initial conditions when you get a 0 in there because, right, doesn't time start at 0? It's one of those things where you say it just gives us an initial condition and allows us to find our actual particular solution. And that's it. That's all 4.9. Go do your homework, dude. Go get that shit done. And we'll move on to the next. If you don't know how to find antiderivatives, you are effed trying to do U subs. You don't even stand a chance. So get this stuff down. It's like learning your adding and subtracting. You're multiplying and dividing to get ready to do some algebra. See you in the next one. Chapter 5 will be next.